Hi guys, it's me. I'm sorry that I'm not able to be with you today, but I wanted to make a quick video. It's not going to be the entire class long, I promise, but just go over a few things that we would have done had I been there. So if you look on the sideboard, I first want to give you like a few little hints about this challenge sheet. So that's why I have it up here right now. It's the yellow paper we started yesterday. There was a lot going on in class, like people were making test corrections and asking questions and also work on the challenge sheet. So a lot of different things. I want to make sure everyone's on the right track with it and hopefully maybe give you a little pointer in the right direction if you were stuck anywhere. I am going to collect this on Tuesday. We have Monday off. It's in service, so Columbus Day, I believe. So Tuesday I will be collecting it and it will be for points as well. Okay, and I have your grades all entered in. I'm sorry I can't show you them today obviously, but I will show you those whenever I come back on Tuesday as well. I set time aside for that. So alright, let me just go through this briefly, give you a few hints. I know a few people came over and asked me a couple questions about some of them. The first one's talking about a pentathlon, and no, I agree, you're probably never going to be, scoring an event like this, but it's mainly like the brain thinking, which is why we do these. So this one's saying everyone starts with 1,000 points. The athlete earns 2 points for every half second under the finishing time of 10 minutes and minus 2 points for every half second over the 10 minutes. So if you think of like when you guys run the mile, the lower the time, the better you are. So in part A, they give you the person we're really talking about, an athlete who finishes at a really good time. 9 minutes and 34 seconds. So he's under. So that means his points, he's going to get 2 points added for each half second. So your job is to go in and figure out how many half seconds he is going to get points for. So it's 10 every half second underneath 10 minutes. So he ran it or did it, whatever he was doing, in 9 minutes and 34 seconds. We need to figure out how many seconds less than 10 that is. So 9 minutes and 34 seconds. So you can work that out. Figure out how many seconds that comes to, and that will give you how many seconds. But remember, we're looking for half seconds. So if, let's say you get 50 seconds, that would be equal to 100 half seconds, something like that. And then each of those are 2 points, and that gets added to their score of 1,000. Part B is the other way around. This person didn't finish in 10 minutes, they went over. So you want to figure out how many minutes they went over, or I'm sorry, how many seconds over the 10 minutes. And you can see, well, they went 11 minutes. So that's 60 seconds right off the bat, plus the 2.5. You can go from there. Now that's how many seconds it is, but you want to know how many half seconds. So again, you want to double that to take that into account. And then this person gets 2 points subtracted from their score of 1,000. And then the last thing I want to draw your attention to on this problem is that it says how many more points than his competitor does he have. So they want to know how many more points does this guy have than this guy. That's really what the question's asking. So work it out. No equation is necessary, just kind of thinking through it. This next one, the table shows the areas of two square rugs that stores cells. How many inches longer is the sorrel rug than the shawl rug? So different rugs here. Square inches, they tell us it is a square rug, so we know it's x by x. You don't even really need to use a calculator, and I'm going to ask that you don't for this problem. I know we aren't using them in general, but here specifically, I want you to think about what you do know, like what numbers you can multiply to get something close to this, We know that, 90 times 90 is going to give me 8,100. Well, that's pretty close to 8,281. So maybe just do a little bit of scratch work and go on to the next one and the next one if need be. So that's going to tell you the dimensions of your square, 90 by 90 or whatever it may be. And then similar case here, work with what you know, just like we did in lesson 2.7 where we did this approximating the square roots. We don't always know exactly what they are, but we can approximate based on what we do know. Same concept here, work around what you have. And then it's asking how many inches longer is this rug than this, so you'll get these two numbers, subtract them, and that's going to be your answer. Make sure you label. In the number 3, this one I am going to say if you'd like to use a calculator, go ahead. Okay, calculator allowed, which is why I wanted to note this here. Here they're saying that you and your friend are comparing two 6-sided cubic storage bins. So basically you have two cubes that are storage bins. One of them is yellow and one of them is blue. So the nice thing here is the fact that because they're cubes, this side is the same as this side is the same as this side. They tell us the surface area. Now just so you can remember what surface area is when you add up all of your sides. So there's 6 of them. They just say that it's completely covered. It's not like the top's open. So you're going to find the area of this side, this side, this side, this side. And basically you'll be able to write an expression. And so if you think about it, the area of just this side, we know how to find the area of a square. You can figure that out. And there's 6 of those. So it's really just going to be 6 times whatever that is. It's going to equal 9,600. Same thing's going to go for this one. So just reviewing that again, you know how to find the area of a square, right? And we're just going to label it x by x at this point. You have 6 of those sides. If you think about a square, a cube, you have 6 sides. A little rough there. We have the one in the front, the one in the back, the 2 sides, and the top and the bottom. So you have 6 sides. Each of them are x by x. That should give you your expression for the total surface area, and they're telling you what it equals. So that's part A. Part B says which bin costs less per, this is our rate, cubic centimeters. So that means you're going to want to find the volume, and this is where your calculator is really going to come in handy. Cubic indicates that we're doing volume. So once you find your number here, that's how long x is, then volume is length times width times height. You can just multiply all them together to get the volume for the yellow bin, and then the volume for the blue bin. Now they're saying the cost per cubic centimeter, so that's cost per cubic centimeter. So really that's the expression you're going to use to figure it out, and this is where you can put your calculator in hand as well. If you're having 9,000, or whatever your volume is, I'm sorry. Let's say this comes out to be 10,000, I'm just making it up. You divide the cost, which was $25, by the 10,000. Okay, so cost divided by your cubic centimeters, this is, whatever answer you get for your volume is cubic centimeters. I'm going to leave this up in addition to you guys doing it today so you can check it out later. Maybe just once you revisit it, if you haven't had a chance to look at it too closely, it might make more sense later. This one is pretty more straight line from what we've been doing. It's talking a lot about a lot of the things we did in class, writing equations. Ooh. So you should be okay with that one. First, write an equation of c of the function as a function of x. So make sure x is inside. I think a few people asked me questions about those word problems on your test, so we should all be squared away. And I think then from there, part B, you're just going to substitute 100 in for x into your equation. And part C, the only little thing I would draw your attention to is it says if the soybean section has a length of 250. So that means if this here is 250. Okay, so be careful. It's a little different than the one above. All right, those are challenged for a reason, and I applaud your going forth and really trying on them, and I will be grading them for accuracy. Like I said, we do them at the end, so it kind of reinforces and takes it a step further and pushes our brain thinking. Last thing I want to do on this is just reinforce what we were doing yesterday. I hope I didn't make it sound not interesting. I think it will be kind of really, really neat. And just to review again, you're right now just thinking of different things you might want to make. So you can type in, I typed in custom, I didn't even type in hats. I typed in custom and that just came up. But there's all these things out there that you can make or sell. Like here's a bunch of bags. Anything you basically ever see, someone had to throw a logo on it and have it printed. Now these are the companies that print them. So as a class, that's exactly what we are going to do. We are going to pick maybe, caps and hats. And whatever you guys think might be fun to like print and actually design something for and sell it at like lunchtime to Marshall Middle School to sport teams, whatever, things like that. That's what we're going to be looking into. Maybe knit caps, maybe those are more popular. I don't know. So we can look into different things that we think might really sell. And our job then, after we pick this up, is going to be come up with a logo and then pursue some different math stuff we'll be learning about in the next chapters to see, how much money we can really make. And my goal is hopefully if we make enough, we can have a pizza party since we aren't doing the picture puzzler, and then maybe donate the rest of it to some kind of charity of sorts. But that's a little down the line. So right now, like I said, we're just looking for different things that we might want to sell. This was the environmental friendly link. So check it out and make a list on your paper there of things that you think would be good, you know, that people would be interested in buying, so that we can maybe really make a profit. Like I'm talking like truly send it away and make money on this. So that's where we stand there. Okay? All right, if you could now, please take out your chapter packets. We're going to work through lesson 3.1 and 3.2. I'm not doing all of them because, like I said, I'm not there, and it's a lot different when you're just listening. Here, I will draw a little sketch of me. Okay, so here's me talking to you, so you're not just thinking this is a random voice. I'm pointing at the board. I do want to go through lessons 3.1 and 3.2. It's all review, so you probably don't even need this, so I'm going to move rather quickly. If you do need anything to be revisited, feel free to watch this later or even ask the teacher that's in there to pause with you. But starting out, inverse operations are two operations that undo one another. So for instance, adding and subtracting, multiplying and dividing. When you square something and when you take the square root of, oopsies, not a 2, square root of something. So adding and subtracting, multiplying and dividing, squaring something and taking the square root of that same thing. So here this x is a variable, here it's multiply. They undo one another. Now whenever you solve equations, you do the same thing to both sides of the equal sign. You have to keep it balanced. When you do that same thing, maybe you add 5 to both sides, subtract 3, whatever the case may be, you're producing equivalent equations. And these are two equations that result from using inverse operations, and they have the same solution. That's how you know an equivalent equation. If you substitute a value in for x in the original and maybe the end one, if the answer is the same, they are equivalent. Okay? For the time being, I'm going to skip over these properties. You're welcome to read them. Adding and addition and subtraction property of equality, just say if you add or subtract the same thing from both sides of the equation, you produce an equivalent equation. So for part A, y plus 23 equals 40. We're going to subtract 23 on both sides. I subtract those. Y is going to equal 17. I could always check this by substituting it back in, and I would see that my solutions are equal, so these are equivalent equations. Okay, so that's really what that definition means. And letter B, this is a minus 19, so remember that subtraction's minus. We're going to add 19 to both sides. I get t equals 40. Okay, I know we've been doing, or not 40, 50. I added wrong. We've been doing equations quite a bit, so we've been solving a good deal of things. So I know these aren't new, and you visited way harder equations last year, but just starting out, we do want to address all of them. So those were those two. Multiplication property of equality and division property of equality says that when you multiply both sides of an equation by a non-zero number or divide by a non-zero number, you produce equivalent equations. And just again, they use that non-zero because you can't divide by 0, like c cannot be 0. That's why they put that term in there. And when you multiply, they're thinking more along the lines of something like this. If you have x over a equals b, to get a out of the denominator, you're going to multiply both sides of the equation by a. Well, a is not allowed to be 0. You can never have 0 in the denominator. So that's why they put in their non-zero number. We talked about why you can't divide by 0. We did the little, the trust fall. But just another quick analogy of it. If I think of inverse operations, since that's what we're talking about here, they undo one another, like we said. So if I have 0 divided by 5, we know that the answer is 0. And I can check it by multiplying 0 times 5, and it gives me 0. So it checks out. The inverse operation works. Whereas if I go the other way, 5 divided by 0, if I say equals 0, well, is 0 times 0 5? No, so that way doesn't work. What if I say 5 divided by 0 equals 5? Is 5 times 0 5? No. So there's no way you could ever figure that out. So it doesn't work when you use the inverse operation, which is why you cannot divide by 0. All right, let's keep going. On the next page.